Welcome back to STEM Academic Education. Good morning, dear students. Today I am going to solve some problems of surface area and volume exercise 12.1 question number 4 to onwards. Question number 1 is a cubical block of 7 side 7 cm which is surmounted by a hemisphere. What is the greatest diameter the hemisphere can have? Find the surface area of the solid. Use pi is equal to 22/7. A cubical block of side 7 cm is surmounted by a hemisphere. What is the greatest diameter of the hemisphere can have? Find the surface area of the solid. The cubical block of side 7 cm which is surmounted by a hemisphere. Surmounted by a hemisphere. Okay. This is a cubical block and surmounted by a hemisphere. This block. The cubical block of a side or edge is 7 cm. Then, if hemisphere is surmounted the cube, then the diameter of the hemisphere will be 7 cm. Right now, what is the greatest diameter of the hemisphere? 7 cm. Right now, what are given? Pi, using pi 22/7. Okay, right now. We have to find the total surface area of this solid. Okay, right now. Radius of hemisphere. Radius of hemisphere will be 7/2. The diameter of the hemisphere will be 7. The radius will be 7/2. Radius of hemisphere R is equal to 7/2 cm or 3.5 cm. Then total surface area of solid. Also side of a cube given 7 cm. Total surface area of solid will be curved surface area of hemisphere part, surface area of the right now, total surface area of a cubical part plus curved surface area hemispherical part and minus base area of hemisphere. Base area hemisphere. Why base area of hemisphere is subtracted from this? The total surface area of the solid, curved surface area of the hemisphere, okay, total surface area of the cubical box. Where hemisphere is surmounted above the cubical block, then this portion area, the hemispherical part, the base of a hemisphere which is lie above the cubical block. So this area covered. So we need not to find the base area of the solid, the base area of the hemisphere in this solid. Total surface area of the cubical part is 6a square plus curved surface area of a hemispherical part is 2 by 3 pi r square. Then base area of hemisphere is pi r square. Then putting the value of this, putting the value 6 a square, 6 into a square means 7 the square plus, sorry, hemisphere was 2 pi r square. 2 pi, putting the value of pi, 20 by 7, radius is 3.5 per square, minus 22 by 7 into r square, 3.5 per square. 6 into 49 plus 2 into 22 by 7 into 12.25 minus 22 by 7 into 12.25. 1.75, 1.75. 6 into 49 to 94 plus 44 into 1.75 77 minus 38.50, 294, 77 minus 38.50 also, minus 38, sorry, plus 38.50. Then 294 plus 38.50 will be 0.50332.50 centimeter square. This is the required answer. A hemispherical depression is cut out from one face of a cubical wooden block such that here a hemispherical depression is cut out from one side of the cubical wooden block such that the diameter of the hemisphere is equal to L of the hemisphere, which is equal to the edge of the cube. L is the also edge of the cube, and diameter of the cube of the hemisphere is also L. Determine the surface area of the remaining solid. Depression: a hemispherical part whose diameter is L is cut out or removed from a cubical wooden block which edge is also L shape. We have to find the surface area of the remaining solid. Write down what is given. Diameter of hemispherical part is L. Diameter of a hemisphere is equal to edge of a cube, which is L. The diameter of the hemispherical part is equal to the edge of the cube, which is L. Then radius of a hemisphere will be are equal to L by 2. Total surface area remaining solid will be surface area of a cubical part minus curved surface plus curved surface area of hemispherical part. Surface area of a cubical part is 6a square plus 2 pi r square. 6 into L square plus 2 into pi r square means L by 2 square. 6 L square plus 44 L square by 7 into 4. 2 square 4. 28 into 6 L square. We put 11 by 7, 11 L square by 7, then 42 L square plus 11 L square upon 7, 53 L square by 7, 53. The medicine capsule is in the form of a cylinder with 2 hemispheres. Total length of the capsule is 14 mm. The length of the entire capsule is 14 millimeter and the diameter of the capsule is 5 mm. Diameter of the capsule is 5 mm. Then, if diameter is 5 mm, then the radius will be radius of hemispherical part is 2.5 mm. Radius of the hemispherical part is 2.5 mm. Then height of the cylindrical part. This is the cylindrical part, and this is the hemispherical part, and this one is hemispherical part. Then height of the cylindrical part will be 14 minus 2.5 feet plus 2.5 minus 5 is equal to 9 mm. This is the height of the cylindrical part. We have to find its surface area. Okay. Write down. Radius of hemispherical part high by 2.5 mm, and the height of the cylinder also, height of cylinder 14 minus height 2.5 plus 2.5 minus 5, 9 mm. Then we have to find surface area of a capsule. Surface area of capsule, curved surface area of a cylinder, curved surface area of a cylindrical part, plus 2 into curved surface area of hemispherical part. Hemispherical part. Curved surface area of a cylindrical part is 2 pi RH, 2 pi RH, 2 into curved surface of a hemispherical part is 2 into 2 pi r square, 2 pi r square. Then 2 pi RH, 2 pi r square. Taking common 2 pi r, 2 pi r h plus 2r. 2 pi r to 4 pi r square. Okay. 2 into 22 by 7 into 2.5 equal to height of the cylinder is 9. 9 plus 2 into 2.5. 44 into 2.5. 44 by 7 into 2.5, 9 plus 5. 44 upon 7 into 2.5 into 9 plus 5 is 40. You can cancel it. 7 to 2.5 into 2 is 5. 5 into 44. 220 millimeter square. 220 millimeter square. This is the required answer. Next. Surmounted by a conical top, and the height and diameter of the cylindrical part are 2.1 meter and 4 meter respectively. Height of the cylindrical part is 2.1 meter and the diameter is 4 meter. Respectively, and the slant height of the top is 2.8 meter. Slant height of the top part means the slant height of the core is 2.8 meter. Find the area of the canvas used for making the tent, and find the cost of a canvas of the tent of the rate of 500 per meter square. Note that the base of the tent will not be covered with the canvas. The base of the tent will not be covered with the canvas, and we have to find the area of the canvas used for making the tent. That means we need to find the surface area of this solid, curved surface area of this solid. What are given, write down. And this, the radius of tent will be 2 meter. Write down. Height of the cylindrical part. Height of cylindrical part is 2.1 meter. Then radius of cylindrical part 4/2 meter. Then radius of cylindrical part 2 meter. Slant height of the cylindrical part, conical part. Slant height of conical part L equal to 2.8 meter. Then we have to find area of canvas used. Area of canvas used. Area of curved surface area of conical part plus curved surface area of cylindrical part. Conical part, the curved surface cone is pi rl plus 2 pi rh. By taking common pi r, L plus 2h. Putting the value for pi is 22/7, r is 2 plus L. 2.8 plus 2 into 2.1. 22, 44/7 and 44/7 into 2.2, 2.8 plus 4.2. 44/7 into 7.0 or 7 cancel, 44 meter square. The canvas used 44 meter square. Then cost of 1 meter square is 500. Then cost of 44 meter square will be 44 into 500. Ruler 22,000. Okay. Then